Hello children, let's read this question. A given sample of milk turns sour at room temperature, that is equal to 20 degrees Celsius, in 64 hours. In a refrigerator at 3 degrees Celsius, milk can be stored 3 times as long before it sours. Estimate the activation energy for souring of milk and milk to sour at 40 degrees Celsius. So please note that key concept of this question is rate of reaction is inversely proportional to time taken to complete the reaction. Let T1 is equal to 20 degrees Celsius, that is equal to 293 Kelvin. T2 equal to 3 degrees Celsius, which is equal to 276 Kelvin. And T3 is equal to 40 degrees Celsius, which is equal to 313 Kelvin. At T1 equal to 293 Kelvin, time taken to sour the milk is equal to 64 hours. And at T equal to 3 degrees Celsius, time taken to sour the milk is equal to 3 times of that of A. So K1 upon K2 is equal to T2 upon T1. That is, K1 upon K2 is equal to 3 T1 upon T1. This means K1 upon K2 is equal to 3. And we know that rate of reaction is equal to A into e to the power minus EA upon RT, where A is pre-exponential factor or Arrhenius factor. Pre-exponential factor and EA is activation energy. R equal to rate constant and T equal to temperature. So K1 is equal to A e to the power minus EA upon RT1 and K2 is equal to A e to the power minus EA upon RT2. So ln K2 upon K1 is equal to EA upon R 1 upon T1 minus 1 upon T2, which is equal to ln K2 upon K1 is equal to EA upon R T2 minus T1 upon T1 into T2, equal to ln K1 upon K2 is equal to EA upon R T1 minus T2 upon T1 into T2, which is equal to 2.303 log with base 10. K1 upon K2 equal to EA upon R T1 minus T2 to T1 into T2. Now K1 upon K2 equal to 3, R equal to 2 calorie, T1 equal to 293 Kelvin and T2 is equal to 276 Kelvin. So 2.303 log 3 is equal to EA upon 2 calorie into 293 minus 276 upon 293 into 276. So EA is equal to 2.303 to 2 into 293 into 276 into log 3, which is equal to 0.47712 upon 293 minus 276, which is equal to 17 calorie. So EA equal to 10,454 calorie, which is equal to 10.454 kilocalorie. So activation energy of the reaction is equal to 10.454 calorie. Answer. Let's proceed to second part of the question. In the second part of the question, we have to find the time in which the milk sour at 40 degrees Celsius. As we know that rate of reaction is inversely proportional to time. This means K is inversely proportional to time. Here T1 is equal to 293 Kelvin and T2 is equal to 313 Kelvin. Time taken by milk to sour at 20 degrees Celsius is 64 hours, and we have to find the value of T2, which is equal to the time in which milk sour at 40 degrees Celsius. And we also know that value of K varies with temperature at e के power minus E upon RT. So K3 upon K1 is equal to E के power E upon R T1 minus 1 upon T3. So ln K3 upon K1 is equal to E upon R T3 minus T1 upon T1 into T3, which is equal to 2.303 log with base 10 K3 upon K1, and activation energy is 10,454 and value of R is 2 calorie and temperature T3 is equal to 313 and T1 is equal to 293, 313 into 293. So log 10 K3 upon K1 is equal to 10,454 into 20 divided by 2 into 313 divided by 293 divided by 2.303. This means K3 upon K1 is equal to 3.12, and we know that K is inversely proportional to 1 upon time. So K3 upon K1 is equal to T1 upon T3, and K3 upon K1 is equal to 3.12 and T1 is equal to 64 hours. So T3 is equal to 64 hours upon 3.12, which is equal to 20.5. So T3 3 is equal to 20.5 hour. This means 20.5 hour. This means in 20.5 hour milk sour at 40 degrees Celsius. So answer of portion B is 20.5 hour. Hope you all understand it well. Thank you.